Inside Canadian universities, the pressure to publish and secure funding is intense. To keep up, 57% of individual researchers and students are now trialing artificial intelligence tools to accelerate their work. But that speed creates a hidden trap. In a rush to streamline workflows, a researcher might take an unpublished grant proposal or raw, unverified laboratory data and paste it directly into a free commercial large language model like ChatGPT. Warning tone. By hitting enter, they trigger a mechanical cost. The researcher legally strips the federal funding agency of its data custody and permanently leaks their proprietary intellectual property into an open-source training database. The fallout from that single keystroke is severe. It exposes the researcher to academic misconduct charges, breaches strict institutional confidentiality agreements, and triggers direct violations of modernized federal privacy laws like Bill C-36. Artificial intelligence offers researchers an incredible analytical advantage, provided they successfully navigate the complex, multi-tiered gauntlet of Canadian regulatory checkpoints. The first major checkpoint is the initial grant proposal. At the federal level, the tri-agency rules permit generative AI as an administrative tool, specifically for structural drafting, streamlining workflows, or translating language. However, there is an absolute condition attached to that permission. The named applicant bears 100% accountability. They must personally guarantee that every generated sentence is true, accurate, and completely free of hallucinated citations. The rules flip entirely for the peer reviewers adjudicating those applications. Adjudicators operate under a strict, absolute prohibition against using AI to evaluate grants. Inputting proprietary proposals into an AI system is an immediate conflict of interest that causes a catastrophic leak of intellectual property. Before any funded lab work can begin, researchers hit the next gate, the Research Ethics Board. When AI is involved, ethical clearance must happen before a single piece of data is collected. Royal Roads University offers the clearest example of this standard. They mandate that any planned use of AI must be explicitly declared, and participant consent must specifically account for AI data processing entirely in advance of the research project. Bypassing these early grant and ethical approvals transforms a methodology into a career-ending compliance failure before the researcher even sets foot in the lab. Once in the active research phase, laboratories face the data trust gap. This is the friction between the analytical potential of AI and the severe cybersecurity vulnerabilities of uploading raw academic data to the internet. To close that gap, institutions are locking down access. The University of Alberta strictly prohibits the use of free public AI models for sensitive research. Instead, researchers are mandated to use secure, enterprise-level tools accessed through verified campus IDs. The mechanics here are vital. In an enterprise model, the data operates inside an isolated loop. It remains confidential within the university's tenant environment and is physically blocked from ever being used to train public algorithms. But data isolation alone doesn't satisfy provincial law. Jurisdictions like British Columbia and Nova Scotia require highly sensitive data to legally stay on Canadian soil. To solve this geographic bottleneck, the federal government, through the Digital Research Alliance, invested $15 million to build the Distributed Storage and Compute Grid. This creates physical, sovereign supercomputing infrastructure inside Canada. It ensures that massive academic datasets remain legally secure and geographically compliant while being processed by the world's most powerful AI models. After the data is processed, researchers reach the final checkpoint: thesis writing and publication. Here, institutional policies shift the entire burden of proof directly onto the student. At the University of Toronto, procedural integrity rules draw a hard line. Large language models cannot produce true academic originality. Therefore, the non-publishable portions of a doctoral thesis, like the discussion and conclusions, must be written entirely and independently by a human. McGill University handles this with mandatory disclosure frameworks. Students must formally attest to exactly which tools they used, the extent of that use, and how they applied human oversight to verify the AI. These strict university policies are anchored in federal reality. Under the legal standards set by the Supreme Court of Canada, copyright protection requires an author to exercise distinct skill and judgment, involving a non-trivial amount of intellectual effort. Because purely AI-generated text is a mechanical, probabilistic output devoid of human cognition, it fails the skill and judgment test. It cannot be copyrighted, meaning the generated work instantly falls into the public domain, where anyone can legally copy it. Relying too heavily on AI to write a final publication risks academic discipline and legally forfeits the researcher's ownership over their own scientific discoveries. Safe generative AI use relies on structured, intentional research data management. Algorithms can only analyze information that is properly mapped and secured. To handle this, researchers use national tools like the DMP Assistant. This platform helps scientists draft standardized management plans that satisfy federal rules, maintain data security, and ensure the raw science remains findable and accessible. Organizing this data perfectly prepares a laboratory for agentic AI, systems capable of planning, adjusting, and executing multi-step laboratory tasks entirely on their own. Achieving that level of high-speed autonomous science is impossible if the underlying data is a disorganized, vulnerable liability. Maintaining strict regulatory compliance establishes the reliable data foundation researchers need to trust their tools and secure the ownership of their results.